Hello, everyone, and welcome to our webinar. I'm Steve Hill, CEO of NewHydrogen. Today, we're excited to reveal the breakthrough technology that's driving our vision for the future of green hydrogen. Also, we'll learn more about this extraordinary $12 trillion market opportunity. Today, I'm joined by two remarkable leaders in the hydrogen space. First, we have Dr. David Lee, president and founder of NewHydrogen. David earned his PhD in electrical engineering at Purdue University and has spent much of his career developing sources of clean energy. David worked for several years with UCLA to reduce the costs of electrolyzers by replacing rare earth catalysts with earth-abundant alternatives. His experience with electrolyzers has been instrumental to the development of Thermoloop. Next, Dr. Ivor John, our senior advisor and hydrogen market expert. Dr. John, with a PhD in atmospheric physics from the University of Wales, UK, is an expert in hydrogen technologies. He's advised energy companies on emissions and now focuses on hydrogen's role in the energy transition. I might also add that Ivor's owned multiple Toyota Mirais, hydrogen fuel cell vehicles manufactured by Toyota. He truly walks the talk. Welcome, gentlemen. We're all looking forward to your insights today. Before we hear from our experts, though, let's start with a short video that unveils the breakthrough at the heart of NewHydrogen's game-changing green hydrogen technology. We need to talk about hydrogen. Why? Because we depend on hydrogen in ways most of us never realize. It's the secret behind fertilizers that feed the world, an invention that's been called the most important of the 20th century. It fuels vehicles, refines oil, and builds steel, glass, and life-saving medicines. It's clean. When hydrogen is burned, it leaves behind only pure water. In this video, I'll introduce you to our groundbreaking Thermoloop technology that uses inexpensive heat and water to make the world's cheapest green hydrogen. We believe this is a game changer compared to conventional low-performance electrolyzer technology. In fact, Thermoloop can be configured as a drop-in replacement for electrolyzers, making them obsolete. We believe Thermoloop can be an electrolyzer killer. Let me explain. Most of the hydrogen today is made from natural gas, a depleting and dirty fossil fuel. This is called gray hydrogen. However, water, H2O, which consists of hydrogen and oxygen, is a better and greener source of hydrogen, and more than 70% of the Earth's surface is covered with water. So what's the hang-up in making lots of cheap green hydrogen? The primary way of making green hydrogen today is to split water using an electrolyzer, which is powered by green electricity, such as solar and wind. This is a 200-year-old technology and is very expensive. You might be thinking to yourself, there's got to be a better way. Yes, you're correct. There is a better way. Simply use heat instead of electricity. Heat is cheap. Heat can be found everywhere. Sources include concentrated solar, nuclear reactors, waste heat from industrial plants such as oil refineries and cement and steel manufacturing plants. Heat-based systems are more scalable and have the potential to be cheaper than electrolyzer systems. It sounds great, but scientists have struggled for decades in search of an efficient way to use heat to split water. Why? Because the biggest challenge in building a heat system is the temperature mismatch between the different chemical reactions in the process. One reaction extracts hydrogen from water, which usually occurs at a low temperature. Another reaction extracts oxygen from water, which usually occurs at a high temperature. While the system is heating up or cooling down, hydrogen is not being produced and excess energy is wasted. This is incredibly inefficient. Now for the good news. We're inventing a better way to use heat to split water. We're developing Thermoloop, a breakthrough technology that allows all reactions to occur at nearly the same temperature. These reactions are called near isothermal reactions, and the process is called thermochemical water splitting. Easy to say, hard to do. That's why all other thermochemical approaches have fallen short. Stay with me while I very briefly describe our technology. To achieve this holy grail of near isothermal reactions, we're developing novel materials and chemical reactions from the ground up. So when temperature 1 is close to temperature 2, system downtime is minimized. You only have to heat a little bit and cool a little bit, and hydrogen production loops continuously. Very efficient. How do we find this novel material? If you guessed that AI played a role in our scientific discovery, you're correct. Using state-of-the-art artificial intelligence and machine learning tools, we searched the periodic table and played jigsaw puzzle with many different elements to arrive at a novel material with just the right Goldilocks attributes to enable scalable isothermal reactions. Now let me show you some magic. We designed a set of novel chemical reactions using a new paradigm that exploits the phase change properties of our novel material as its components change from solid to liquid to gas and back to solid. It's this phase change that allows us to reduce the temperature difference between the reactions. This is the magic trick that we believe will allow us to achieve near isothermal reactions for the continuous production of hydrogen from water. Finally, we combine all of these innovations to create Thermoloop, a highly scalable thermochemical water splitting system that we believe can produce the world's cheapest green hydrogen. Thermoloop is agnostic to the sources of heat and water. If we simply couple Thermoloop with any available source of heat and water, we can create an incredibly efficient, low-cost, clean and green hydrogen production machine anywhere, anytime. What if heat is hard to get? No problem. Because the thermodynamics of heat systems are more efficient and scalable than electrolyzer systems, we believe we can convert electricity to heat to run Thermoloop and still outperform electrolyzers. Thermoloop is the electrolyzer killer. Join us as we build the green hydrogen economy that Goldman Sachs estimated to be worth $12 trillion. We absolutely believe that Thermoloop will make electrolyzers obsolete. David, let's kick off the discussion part of this webinar with a related question for you. What really is the problem with the old electrolyzer technology?
Thanks, Steve, for the kind introduction. First, we have to keep in mind that the electrolyzer was first invented in 1789. That's more than 200 years ago. Even though there have been advancements in materials and manufacturing, it is important to note that the basic chemistry and architecture hasn't changed much since then. All electrolyzers suffer from some disadvantage. Let me list them one by one. Number one, overvoltage. To drive the meaningful amount of hydrogen production, electrolyzers need much higher energy than what the theory of thermodynamics suggests. This is a reason for lower efficiency. Number two, catalysts are often precious metals such as platinum and iridium. In particular, iridium is the so rare material, it can only be found in asteroids. The bad news is that they all corrode over time. This means very expensive maintenance. For that reason, NewHydrogen previously developed catalysts from earth-abundant alternatives rather than using precious metal-based catalyst. Number three, degradable membranes are needed to separate hydrogen and oxygen bubbles so that they don't go recombine. So another very expensive maintenance item. Number four, precious metals and membranes are highly susceptible to fouling. Therefore, we have to use a high purity distilled water. The current alkaline electrolyzers and PM electrolyzers require high purity water as feedstock, often requiring up to 13% of the total capital cost. Number five, water splitting reactions can only happen on the surfaces of these two-dimensional electrode plates. Therefore, much of the water is waiting around to take their turn. This results in low efficiency and low throughput. Most important disadvantage that electrolyzers have is the high cost of green electricity. The cost of this green electricity accounts for nearly 73% of the cost of producing hydrogen.
Thank you, David. Let's transition and talk about this $12 trillion market opportunity. Yes, you heard that correctly. Goldman Sachs sees the green hydrogen market as a future $12 trillion opportunity. Okay, Ivor, you know this market well. What would you say are the major drivers for this hydrogen market expansion?
Yeah, Steve, green hydrogen is expected to play a significant role in the build-out of the power sector and in future transportation systems. As the demand for clean electricity grows, decentralized hydrogen production, coupled with fuel cell power generation, can alleviate grid stress. Hydrogen also provides a clean, zero-emission fuel source for all forms of transportation. For on-road applications, Steve, we are seeing a big shift from light-duty to heavy-duty vehicles like trucks and buses. Hydrogen technology is particularly well suited for long-haul journeys where batteries are less suitable. It's also well suited for trains and ferries and some forms of shipping and aviation. When hydrogen is fed into a fuel cell, it can power vehicles without releasing harmful emissions. Hydrogen and fuel cells used in heavy-duty transportation not only eliminate CO2 emissions, but also nitrogen oxides and particulates. Hydrogen fuel cells will continue to play an increasingly important role in the transportation sector, and this deserves further mention here. Hydrogen is primarily used to power fuel cell electric vehicles, FCEVs, which only emit water vapor as exhaust. Some electric vehicles contain a battery, and some contain a hydrogen fuel cell and a battery, but all electric vehicles have electric motors. In battery-only electric vehicles, electricity charges the battery directly, and in fuel cell-powered vehicles, hydrogen is stored as a fuel in the tank, and the hydrogen stores the energy which flows into a fuel cell and then reacts with oxygen from the air to create electricity that powers the electric motor. So adoption of green hydrogen in the transportation sector is occurring throughout the world already. Some examples here. Hydrogen offers potential in long-haul heavy-duty trucks, and the US Department of Energy estimates that the total cost of ownership for hydrogen fuel cell long-haul vehicles will become competitive and affordable by 2030. China and Korea both have over 3,000 hydrogen buses and coaches in operation today. And hydrogen trains have been in commercial service in Germany since 2018 and regular service since 2022. And France, Switzerland, California, and Italy have hydrogen trains on order. And then shipping and aviation, we see promising applications for hydrogen in smaller vessels, shoreside operations, and regional aircraft. Companies are already investing in hydrogen-powered aircraft, and hydrogen can also be used, Steve, as a feedstock for other clean fuels like ammonia, methanol, and SAF. So there you are, Steve. There's lots of opportunities for affordable green hydrogen. So there's a ready and welcome place for thermal loop here.
Thank you, Ivor. Transportation is definitely a key driver in the market. Okay, we've got a question coming in from our audience. This one is for David from GH. What are the key features of thermal loop technology that will spell the end of electrolyzer technology?
Well, Steve, I strongly believe the thermal loop technology is very likely to replace conventional electrolyzer technology due to the following two reasons. Number one, efficiency. Thermal loop uses heat that is far more efficient than the way electricity is used by electrolyzers. In other words, the thermodynamics of the heat systems are far more efficient than that of electrolyzers. Number two, scalability. Thermal loop is far more scalable than electrolyzer systems. What does it mean? Well, better scalability means the cost of producing green hydrogen can be drastically lowered with the scale of economy.
Thank you, David. We have a follow-up question for Ivor from KM. Dr. John, thank you for your comments about fuel cells, especially for transportation applications such as electric cars and trucks. However, rather than use fuel cells to produce electricity to run an electric motor, is it not possible to simply modify an internal combustion engine to burn green hydrogen directly? If so, then how will that affect the future market for green hydrogen?
Yeah, Cam, you're correct here. This is a good question. Several heavy-duty truck manufacturers, including Cummins and Mahle in Germany, for example, they're already modifying their internal combustion engines to use green hydrogen instead of diesel through design changes that allow existing diesel engines to run on hydrogen with minimal modifications. And Toyota is also testing this idea for lighter vehicles. So the approach is seen as a potential pathway to decarbonize the transportation more quickly by utilizing existing engine technology with green hydrogen, and then this provides a way for accelerating the installation of fueling infrastructure as performance and cost improvements are attained with fuel cell technologies. So yes, Ken, it's an interesting question and a real transition opportunity here using hydrogen in IC engines.
Thank you, Ivor. Let's take one last question for Dr. Lee from JT. Dr. Lee, I see that your academic work was in the field of electrical engineering. What role does your field of study play in your work today in developing a breakthrough green hydrogen technology?
That is a very good question, JT. When I started my first engineering job in the space industry, I remember my boss asking me, "Why do you think we hired you?" And with some hesitation, I answered, "Perhaps because of my satellite communications background." He said, "Not at all. Your PhD to me is just a proof of your persistence and determination to finish what you started." He then said, "Your learning process starts right now." And so my learning process continues. So often in life, one interesting thing leads to another interesting thing. Without my electrical engineering background, I never would have spent many years to develop a battery for the storage of renewable energy. Without this renewable energy background, I would never have spent many years trying to reduce the cost of electrolyzers. This challenge pushed us to pursue a better way to split water and produce green hydrogen. Ultimately, that led us to the University of California, Santa Barbara. With its world-class engineering faculty, prestigious honors, including multiple Nobel laureates, UCSB offers unmatched foundation for innovation. One of the Nobel laureates with whom I had the privilege of collaborating on another project before certainly exemplifies this excellence. I strongly believe this legacy of groundbreaking achievement is the perfect environment for our thermal loop technology development.
Thank you, David. As we near the end of our discussion, let's take a look at what's ahead for NewHydrogen. Our journey to revolutionize hydrogen production is well underway. We're now entering the next phase of our development, which includes fine-tuning our breakthrough material and validating its potential with a lab-scale prototype. From there, we'll scale to a commercial prototype and eventually construct a full-scale pilot plant, laying the foundation for global impact. Right now, somewhere in the world, a farmer worries about rising fertilizer costs. A transportation company wrestles with high fuel prices. A manufacturer searches for ways to lower its carbon footprint. The solution to address so many challenges like these is within reach. Our journey to revolutionize hydrogen production is about more than innovation. It's about unlocking a multi-million-dollar market poised for exponential growth. With our breakthrough thermal loop technology, we're not just imagining a future of clean hydrogen, we're engineering it step by step. And as we've heard today, the hydrogen economy is set to reshape industries from energy and transportation to agriculture and manufacturing. Thermal loop isn't just a concept, it's a developing solution that we believe has the potential to redefine scalability, efficiency, and profitability in green hydrogen production. As this transformation accelerates, now is the time for you to get involved. Visit newhydrogen.com to see how we're making green hydrogen a reality and how you can be a part of it. And if you joined us late or you'd like to see this webinar again, just hit replay or click on the YouTube link. Thank you so much for joining us. We appreciate your support and we look forward to what we'll build together.